Hello, Assalamu alaikum, Professor Kemal. Can you hear me?
I'm hearing you. Hello.
Hello, Professor. Can you hear me?
Yes, of course. Are you hearing me?
Yes, I can hear you.
Okay.
Thank you very much for joining and for your time. Would you please like to share your slides so that we can see?
Yes, of course. Yes, of course.
Hello. हम्म, क्या मैं इंट्रोड्यूस करा दूं ऊपर आ जाऊं हाँ ओके ओके ओके ओके so right, can you please put it on the slideshow mode?
Yes.
Okay.
Is it seems good?
Yes, yes,
Okay.
yes. Thank you very much. So we'll
Thank you.
just wait for a few more minutes so that we have people joining us
Yeah.
online.
Okay. Okay. We will continue.
Yeah, I'm very happy to see you. Alhamdulillah,
Thank,
after so many, back and forth on the email, we're able to organize this.
thank you very much.
Thank you.
Thank you very much.
Thank you very much.
Thank
So,
you.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and good afternoon, ladies and gentlemen. Good afternoon, good morning to people who are joining us from different time zones. We are back with another exciting talk under Comstech's webinar series. The title of the talk is Management of Drinking Water, Dams and Lake Basins, Depending on the Changing Climate. This talk will be delivered by Professor Dr. Kemal Gunesh. He's a senior scientist at TÜBİTAK Marmara Research Center based in Turkey. With this, I request His Excellency to please introduce and welcome our guest speaker for today. Over to you, sir.
Bismillahirrahmanirrahim. Assalamu alaikum. Good morning, good afternoon, and good evening, ladies and gentlemen. We already have over 40 participants from different time zones, and this is an extremely exciting webinar. This series of webinar by some of the top researchers, scientists, technologists, engineers is a very important program of Comstech. Largely for developing capacity in areas of interest and relevance. And today, this is a very important event on water. Now, Comstech in last 1 month has organized many events on water, including an inter-Islamic networking meeting of Water Research and Development Institution, which was held in Islamabad and attended by participants from 20 countries. And then there was an event on reverse osmosis membrane technologies, which are used for reclaiming and reuse of water. Comstech also has inter-Islamic network on water research and development. And in this context, this lecture is extremely important. And the title of this lecture is Management of Drinking Water, Dams and Lake Basin, Depending on the Changing Climate. And climate is putting a lot of pressure on available resources. OIC is a water constrained region with only 14% of water resources available to 1/4 of humanity. Today's speaker is a very eminent professor, Professor Dr. Kemal Gunesh, from the top institutions of the Muslim world, TÜBİTAK Marmara. I visited TÜBİTAK Marmara several times, and I was extremely impressed from the quality of work being conducted. Today's event is largely developing understanding of how climate is affecting on the management of drinking water, dams, and lake basins. And this is critically important because climate is a major determinant in water resources and other impact. Freshwater resources are among the most vulnerable resources to changing climate. And as a result of it, it's very important that science and technology is being used for conserving water resources. Professor Dr. Kemal graduated from Ankara University Faculty of Agriculture in 1988. He completed his master's in 1992 at the same university with a study on the quality of surface water in Sakarya Delta, and his PhD in 2000 with research titled Testing Natural Treatment Technologies for Recycling Domestic Water, Wastewater in Agriculture under Turkey's condition. In 2003, he completed his postdoctoral studies at the Florida State University College of Civil and Environmental Engineering. And the following years, he implemented numerous pilot-scale and full-scale projects. So he is not only a very high-quality academician, but also practitioners who actually work in the field and has worked on many projects of extreme importance. With this, I'd like to invite Brother Dr. Kemal for his presentation today, which is, I'm sure, is going to be beneficial to all of you. Thank you.
Thank you very much, Dr. Kazima. Dear participants and dear colleagues, I respectfully greet you all you from Turkey. First of all, I would like to thank Comstech and Dr. Kazima Muazim and her team, his team, for planning this organization. I would like to briefly information and our practice on drinking water basin and our projects. And briefly, I give you main idea of freshwater. Freshwater supplies are already under intense pressure due to the increased demand for drinking water due to the population growth. As you know, industrialization, greater demand for irrigation water to feed the expanding population, and change in the land use. In addition, water resources, which are already restricted, also appear to be more fragile due to the climate change and temperature fluctuations, triggering irregularities and amount of this kind of irregularities and severity and rainfall in a given time period. If we give some information about climate change globally, global key indicators climate change here now. According to NASA's latest data, when looking at the certain climate change indicators on Earth, it's observed that CO2 levels have reached 422 ppm. Global temperatures have risen by 1.4 degrees centigrade compared to the pre-industrial era. Sea levels have increased by approximately 10.1 centimeter since in 1993. Ocean heat constant has reached 360 zetajoules, and methane emission also have shown as upward trend at level of 1922 ppm. On the other hand, the Arctic Sea ice minimum extent has decreased by 12% approximately per decade since in 1979. And ice sheets are reported to be losing 406 billion metric tons per year. Similarity, according to finding obtained from the ERA 5 dataset within the Copernicus Climate Change Service, considering that 2023 was 1.48 centigrade above pre-industrial levels, it is reported that the annual temperature in 2024 will exceed 1.5 degrees centigrade above pre-industrial levels, and it's likely to reach or surpass to 1.55 degrees centigrade. And climate change in Europe, I would like to give some information about this area because this area is very important for industrialization. General outcome of this climate change, this area here now. A study on the direct and delayed effects on climate change reveals the Europe faced a severe summer drought in 2022 with significant social economic consequences. Central and Southern Europe experienced that largest water shortage deficit since satellite observation began in 2002. marking the highest level in the past 60 years. The study highlights that while the effects of global warming on drought continue, the risk of drought is expected to increase further in the future due to the intensified human-induced warming. Furthermore, it's a study evaluating the current and future water availability in Europe on a regional basis. The countries at greater risk are Spain, Portugal, North Macedonia, Greece, Bulgaria, Albania, France, and Italy. Additionally, countries such as Slovakia, Ireland, Belgium, Luxembourg, Croatia, and Romania are intensified as being at mild risk, while Northern Arctic countries like Sweden, Finland, Norway, and Russia exhibit strong water availability with a slight increase also observed. A study examining the major impacts of climate change on the agricultural sector in Europe's main biogeographical regions highlights that temperature increases will be significantly higher, particularly in countries bordering the Mediterranean. Additionally, a decrease in rainfall and increase in drought are expected. So it can be said that the Mediterranean basin, where agricultural population production is concentrated, may face substantial losses in agricultural yields. Although similar conditions are expected in Central Europe, and anticipated risks are not as severe as those in the Mediterranean basin, but other parts of Europe issues related extreme rainfall, storms, and flooding emerge as the primary concerns. Importance of climate change in change and water in Turkey. According to the report, the climate of the impact of climate change on water resource project, which evaluates Turkey's 25 water basins up to year to end of this century, significant increases in average temperatures are expected in Turkey. The rise in temperatures is predicted to exceed the anticipated levels by 1 to 2 degrees centigrade in the eastern and eastern and southeastern of Turkey. The temperature increase will be more pronounced in the summer months, particularly in the southern and western regions. A general decline in the total rainfall is projected, except for the Black Sea coast. Here, the Black Sea coast, and this area will increase 150 millimeters. Rainfall decreases are expected to be most severe during the winter months. Significant water shortages are anticipated in this southeast part of the Turkey. Euphrates and Tigris and Konya Kapalı Basin, we say closed basin, Konya closed basin. And the water resources are generally expected to remain sufficient in Marmara, here, this area, Marmara, Susurluk, Northern Aegean, Western Mediterranean, Western Black Sea, Yeşilırmak, Antalya, Aras, and Lake Van basins is available. It's projected. Climate change scenarios also emphasize 25% reduction in water resources across Turkey by end of this century. The decrease in water resources is of particular concern to the agricultural sector, like other countries, as I mentioned before, Europe. Turkey, which has a total surface area 78 million hectares and has 24 million hectares of irrigable land. Technically and economically irrigable agricultural land is only 6.5 million hectares, of which approximately 60% of the 6.5 million hectares of agricultural land can be irrigated. Additionally, Turkey 77% of water, total water use in allocated to agriculture. It is a very big amount if we compare the Europe or other side of in the world. Therefore, the negative impacts of climate change on the agricultural sector are expected to intensify in the future. In this context, rain-fed agriculture is likely to be the most adversely affected by unfavorable climate conditions. As a result, reduction in crop yields and losses in biodiversity are among the other anticipated negative outcomes. And I'd like to give information about our studies in some regions in Turkey. As it's known, the primary priority in water usage in human consumption. For this reason, in order to ensure the regional management of these valuable resources in the coming years, we have completed projects for approximately 30 drinking water basins, taking climate scenarios into account. These study depend on the legal obligation according to regulation on the protection of drinking water basins dated 2017. It is obligatory to prepare the basin protection plans. As a result, in order to protect and improve water quality and quantity on a basin basis, its social, economic, physical, geographical, hydrological, hydromorphological, ecological, and chemical components or properties should be determined based on the detail of site-specific study. If we look at the methodology of preparing these projects, we focused on data collected from a site currently or before obtained data we used. And we create a method, how can we regulate these data. And we also use hardware, software, and we have many experts allocated these kind of projects. And the GIS or GIS group also has jobs in these projects. Basin protection plan preparation experts here now it's listed. Climate change scenario experts, water and wastewater treatment experts, geology and hydrology, landfill, agriculture, air quality, architecture, limnology, environmental scientists, sociologists, GIS group, modeling. Also, we use generally SWOT, soil water assessment tool model, but other kind of model also be used this kind of basin project. For example, WASP is other good model to modeling the area. And water quality tool we also modeling used. Mainly we used a VET model for measure the water quality in the reservoir. And we have our GIS group also preparing the mapping area before starting field work. The GIS group determines the boundaries of the basin at high resolution. Then maximum water level is then indicated on the created GIS map, and the basin divided into sub-basin, or the other name is micro-basin, and detailed. I'd like to give you, excuse me, an example. This is the west part of Turkey, Marmara region, Büyükçekmece Lake Basin. As you've seen here, our basin border is colored with here, and our lake and surrounding area detailed creeks or other land use, for example, agriculture area, settlements, etc. We took a lot of samples in the lake and surrounding creeks and other parts of the basin. And mapping, as you've seen before, we indicate all land use in the basin, for example, forest, settlements, and the other land use. Then we give all data to the our modeling group. You see now Büyükçekmece Lake Basin and other Sapanca Lake Basin here in this slide. And we also create a digital elevation model is an absolutely necessary study for all planning in the basin, because all flooding or other dirties or other pollutants, how can reach to the reservoir. The data also necessary for modeling tool. And the other land use map, also digital elevation model and other land use map. All map is evaluated together. And sub-basin, as I mentioned before, or the other name is micro-basin, is very important, because if we divide the basin, different micro-basin, we evaluate all detail in the small parts in the basin very effectively. And all data in the micro-basin given directly to the model also. We take many precautions and many work in micro-basin if necessary, because many micro-basin has different character. So we focused if the macro basin is problematic or other conditions. In this slide, you now see primarily dam basin. We divided into 66 micro basin. We divided one basin into 66 micro basins. And field study also very important. We collect data from the background or for many years data we evaluate, but field first of all streams, lakes in the basin are monitored at least 1 year. The latest data is very important, and we measure all data monthly and seasonally. Because our model is used monthly also. Seasonally data depends on the parameters. In the studies, the data all of previous studies are also evaluated, as I mentioned before, in the Lake River monitoring studies. All parameters, about 450 parameters, macropollutants also evaluated in the relevant regulations are monitored on the seasonally and monthly. Field studies continue. In addition, heavy metals monitoring is carried out in the lake reservoir bottom sludge at various points of the lake or dam lake. At least 5 points we select in the bottom of the dam or lake. Then we analyzed, we evaluate further or now how kind of pollutants, especially heavy metals or other organic pollutants are settled in the sludge. On the other hand, surface and groundwater monitoring studies are also carried out. In this context, we will monitoring well and spring waters. Approximately 60 parameters are monitored twice a year, because dry and rainy period is very important. Dry period is September and December, and rainy period in Turkey, March, April, and May. Monitoring of pollutant sources. As you know, pollutants on the left are easier to control because point source very important, but is controlling very easy. But non-point source in the total source, while those on the right are more difficult and more expensive to control. But we monitor all studies, pollutants coming from point source and non-point source. Some example, for example, agricultural activities is located into non-point source, leachate, water, septic tank, land use activities. But we create some precautions about each point of pollutants. How can we regulate correctly? And water budgets is also very important. I'd like to show you like a hand calculation as an example, but normally we use this calculation with modeling because all land use and meteorological data use an input into the model. then model calculate all data and create how much budget flooding to do dam or a lake reservoir. And basin modeling is what, as I mentioned before, we mainly used for creating these scenarios. Scenario is very important for protection of lake basin, and we choose the best one for which scenarios is fit to our goals. We choose the best one, and we continue on this scenario. For example, basin modeling scenarios, water quality in the lake according to the current situation in the basin. For example, 90% treatment of all wastewater, but current agricultural activity remains the same. The other scenario, 90% treatment of all wastewater and 30% reduction in livestock. And the other is 90% treatment of all wastewater, 30% reduction of animal husbandry, and 20% reduction of irrigation, or for example, transfer or alter the existing irrigation system to pressurized system. Then one of the scenarios with the highest applicability is selected. All activities in the watershed are re-evaluated according to the criteria in the selected scenario, and existing lake protection zones are cancelled, and recreated protection zones are taken as basis. Basin-specific discharge criteria are determined because of the current data. Responsible institutions are determined for each activity. And we prepare a specific regulation process. Then defined deadlines are determined. Deadlines are determined for activities aimed at the preventing pollution. The regulation and protection plan prepared specifically for the basin are discussed with all stakeholders. Then after a consensus with the stakeholders, it is submitted to the relevant ministry. And finally, the accepted new regulation is presented to the opinion in the local people. And the relevant ministry may rearrange some articles if it necessary. Finally, the regulation and the watershed protection plan enter into force. This is the completed water protection plan. Each zones, as you know, as you see the picture, different color. Each zone includes different protection strategies, and the activities that can and cannot be done in each protection zone are clearly stated in the regulation prepared within this scope. And some drinking water dam being worked on in Turkey here. Thank you very much for your attention. If you have any questions, I will answer.
Thank you very much, Professor, for the comprehensive talk. If you allow me, can I take some questions for you?
Yeah, of course.
So we have some questions in the chat box by some of the participants. So I'll just begin with the very first one. So there is Miss Samhan. She's asking, what are major pollutants at Turkey, and how are you monitoring uh, these pollutants, or is there any institution for this kind of monitoring?
Yeah, we monitoring all water, lake or other rivers and other small water budget in different region. Minister of Environment or Minister of Agriculture also and other part of the responsible institution continue to monitor for different parameters. Mainly in this basin, we face to face the mainly nitrogen, phosphorus, and other macro pollutants because it's very important for water quality in the located in the basin. So in some studies, we continue all parameters located in our regulations. So some parameters monitoring monthly, or some of them is monitoring of daily, etc. It depends on the institution use. Now Turkey is continue measure all basins monitoring the rivers and other water budget.
Thank you very much for your answer. So there is another question by Mr. Shahzeb Arif. He's asking, what about water life conservation? I think he's talking about organisms that are living underwater. Are there any, any measures for preserving or conserving these species?
Can you please again repeat
Yes.
again?
So the question is, what he wants to know about the steps taken for water life conservation in Turkey.
Yeah. We in Turkey we conserve all water mass because many years ago we start to monitor all water mass in Turkey. It starts beginning of this century. And many projects in Turkey, our institution, the TÜBİTAK Marmara Research Center, prepared 25 basin projects, all projects. We plan all these water basin projects in 2013, I think. Yes, we finished. But after that, related ministry and ministries because water is used different ministries and different approach. So they every ministry continue their monitoring for their aims, and nowadays we very strictly monitor all water mass and reported to the government. So we also taking account the considering also climate change. We finished climate change scenarios in Turkey 2016, about 10 years before we finished, but now we continue the new model, very high resolution. It's accepted in EU countries also for by 4 kilometers gridial resolution are used in the new model. The first one, 10 by 10 grid resolution is used, all water basins. It's very good, important. It's very nice and very good. It supply us very good, important. In next, I think, in few years, if we got it, the new climate change scenarios, we regulate all water budgets, and we allocate again all water mass to the different sectors. It's very important.
Okay, thank you very much. So I'll just take another question, the last one, I think. Ms. Hera Iqbal, she's asking, I think you have used this word of drinking water dam. So she wants to understand what do you mean by using this particular word, basically a phrase, drinking water dam. I mean, are there dams which are only specified for the use of the drinking water?
Yeah. No, normally, mainly the regulation is, say as, at first you allocate water to the human consumption, the first, because the regulation. And the second, you can use for environment. The third, for regulation basins, so you can use agriculture, then you can use the water from to industrial area, because step by step it's allocated different sectors. For this reason, very important drinking water dam protection. Otherwise, we cannot survive. So, big cities like Istanbul, about 16 million people live there. So we have to protect all water reservoir for human consumption. If we need more water after human consumption, we will be in the next, we can use seawater for desalination, for example. As a result, we focus now drinking water for dams, but it's also used for agriculture or other sectors, because we have an water allocation plan. All Turkey now, in few years later, we will be finished. It will be finished in few years. So, for example, east part of the Turkey has less industrialized area. This area, if this area has a dam, it can use for drinking, irrigation, or other purposes. It's no problem. But mainly we indicate drinking water is very important. After that, we can use all water, other sectors, if available water we have.
All right. Thank you so much. I think there is another question which is probably following up the answer that you just explained by Mr. Idris. He's asking, how about the introduction of industrial wastewater into the basins? Are there any regulations? That's the first part of the question. He's also saying, what about examining the livelihoods of surrounding people to determine those that can have less significant impact on the basins? And are there any efforts toward incorporating water basins and development in Turkey's NDCs, I think national determined contributions or something, as required by UNFCCC?
Yeah, thank you. Yes, we consider these, yes, all water basins. We consider these water mass to every usage. And industrialized area, we offer them, they can use their water for other usage. For example, if they has some pollutant water, they can use they can treat it. Then after they can use it again. It's the concept because the regulation also forced them to use their water use and again, because reuse and recycle process is very important if you have a industrial area in big cities in the basins of drinking water. The regulation is very strict at that time. Otherwise, the preparing aims of these wastewater, wastewater using again and again. It's very strict in the, for example, west part of Turkey. But in the east part of Turkey, in the drinking water industries, maybe a little bit not strict than if you compare the other. Because we focus on our water budgets. Water budgets first used in human consumption, then other is continue the step by step. So our regulation is preparing at these basins. Okay.
All right. Thank you so much, Professor. And with this, we come to end of our webinar. On behalf of Comstech and Professor Dr. Iqbal Chaudhry, I thank you for your time and for the wonderful presentation. I would also like to thank the participants who joined us from different countries. And to all the participants, you will receive your certificate of participation for this webinar through your emails. And with this, thank you very much, Professor. Thanks again. And I hope to see you and also see our participant in another webinar, inshallah. Thank you and bye-bye.
Thank you very much. Thank you.